Hey!
Hi guys, welcome to We'll Knock Your Socks Off. How can I help you today?
We're looking for a pair of socks that fits the shape
Center and spread
of our feet.
Okay, perfect. Let me check my inventory. Looks like we're all out of foot socks, but I have statistical socks.
What are those? Is that like a new brand or something?
Socs is an acronym for shapes, outliers, center, and spread. It's used in statistics for describing a distribution of data after it's plotted in a dot plot, stem plot, box and whiskers plot, or a histogram.
We'll take one of those.
2.
So, the first S in SOCS stands for shape. When a distribution of data is graphed, it takes a certain shape. The first shape we have is uniform, where all data values are evenly distributed. Then we have symmetrical. That can be shown by the normal distribution, which is also a unimodal distribution, which means that it has one peak. Next, we have bimodal, which looks like this. And finally, we have left skewed and right skewed. In a right skewed data plot, the mean is greater than the median, while in a left skewed, the median is greater than the mean.
Okay, the O in SOCS stands for outliers. Outliers are any extreme observations or any values that differ from the overall pattern. So the way we find outliers is by using IQR or standard deviation. So IQR, we find this by doing Q3 minus Q1. Once we find our IQR, we multiply it times 1.5 to find the number. Let's call that number X for right now. After we have found X, we're going to do Q1 minus X equals, let's just say A, and Q3 plus X to, let's just say, equal B. This gives us our interval of data points for the set of data. So if any values don't fall between this interval, then they're outliers. But if they are all in this interval, then they're part of the normal data set. So the second method of finding our outliers is using the standard deviation. So we want to make sure that all the values fall between two standard deviations of the mean. So we want to make sure that we have mean plus sigma, which is all of this part here, and then mean minus sigma, which is all this part here. So if the data values stay between this, that means that they're usual, but if they're anything out of the two standard deviations, that makes them unusual.
Okay. The C stands for center. The center is the expected value of a set of data. The first measure of center is the mean. You can find the mean by adding up all the data values and then dividing by the number of data values in the data set. The mu measures the mean for a population, and X bar is the mean for a sample. The median is the data value that is found in the middle once all the data values are put in order. The mode is the data value that is repeated the most in a data set. So if you have a data set like this, 3 would be the mode because it is repeated the most often. Mid-range is found by adding the first value in the data set plus the last value in the data set and dividing by 2. If I were to calculate the mid-range for this data set, I would find it by adding 1 plus 4, which equals 5, and then dividing it by 2, which is equal to 2.5. If there are outliers, the best measure of center would be the median, as it is resistant to outliers, while the mean is not.
So the last S in SOCS is spread. The first measure of spread is range. Range is the last data value minus the first data value. The next measure of spread is IQR. IQR is Q3 minus Q1. The IQR tells you the middle 50% of the data. Next, we have standard deviation. Standard deviation of a population is represented by sigma, and standard deviation of a sample is represented by S. The formula for standard deviation is the sum of X minus the mean squared over n minus 1, all under the square root. This tells you the distance of each data value from the mean. The last measure of spread is variance. Variance is just sigma squared. And what the variance tells you is the average squared distance from the mean. Ready?
Okay, so we're going to try an example problem. The data values we have here represent the amount of money people spend in our Socs store in one day. So we're going to first calculate the mean, the median, all of that stuff. So first, we're going to put our data values all in list 1. So here I have all of our data values that I entered. Okay, once we have the data values, we're going to go to list, calc, one variable statistics, make sure it's in the correct list we put it in, and then press calculate. So here we have our mean, our standard deviation, our n, which is the amount of values we have, our min, Q1, median, Q3, and max. So the min, Q1, median, Q3, and max represent a 5-number summary, which makes it easier to explain the data quickly. So I'm going to write this all here. Okay, so the box and whisker plot is used to visualize the center and shape of our data. So first I put where the median is, which was 7.5 right here. Then I put Q1, which was 6. Then I put Q3, which was 13 right here. The min value of our data, which was 1. And the max value of our data, which was 25 right here. So now we're going to find the IQR to see if there are any outliers in the data. So from what we said before, IQR is equal to Q3 minus Q1. So this is equal to 13 minus 6, which is equal to 7. So then we have to multiply IQR times 1.5. So 7 times 1.5 was equal to 10.5. Then we want to subtract our Q1 minus 10.5, which gave us 4.5. And then we want to add our Q3 to 10.5, which gave us 23.5. So this gave us the interval of data from 4.5 to 23.5. And clearly we do have outliers because there are values below 4.5, 1 and 3, and values above 23.5, 25.
For shape, we would put that the distribution is right skewed. We can see this on the box and whiskers plot because the right tail is longer and there's more variability, and the mean is also greater than the median. And also on the box and whiskers plot, the median is closer to Q1. An outlier is any extreme value that lies outside the interval that was determined by the IQR times 1.5 method, which gave us 4.5 to 23.5. So the outliers in this distribution would be 1, 3, and 25. For center, we found that the mean is 9.42 and the median is 7.5. As the distribution is right skewed and not symmetric, we would use the median, which is 7.5, as it's resistant to outliers, and there are 3. And lastly, for spread, we found that the range would be 25 minus 1, the largest value minus the first value, which would equal to 24, and the standard deviation is equal to 6.19.
We hope we knocked your socks off!